Thank you. Thank you. Let me first tell you what is my plan for today. We have this homework, and homework is Ruby homework that has 4 problems. And the first one is simple, show all control structures. But number 3 and 4 are creating a class and then making inheritance. So in my opinion, it is better that we speak about object-oriented programming today, and then we return back to those topics that remain to be covered next week. But I would like you to be capable to work on homework right now. So I'm going to jump to slide 178 here, which is object-oriented programming in Ruby. And Ruby is defined as 100% object-oriented language. That means that the whole language is defined as inheritance from an object that is a general object that has all properties that are properties of a root class. So this is the root class called object. And then all other classes are inheriting from that object. So for example, you have that inheritance is based on inheriting numerical classes, and then so numeric class are inheriting from object, and then integer is inheriting from numerical, and complex and rational and float, all of them inherit from numeric. And then previously integer had 2 children classes, fixed numbers and big numbers, and they are now merged together, no longer supported. But the whole structure is always a tree, that you have this root class object, and then everybody inherits from it. Of course, if you have here your own class that you define, then that's fine. But you can take each of these classes and you can expand them by making more components to it. So what I'm going to do today, I'm going in a single lecture show you everything that exists in object-oriented programming in Ruby. And this is 50% of your homework and 25% of your final exam, because final exam always has the 4th problem, that is create a class and show inheritance. Therefore, this is something that is going to be useful to you. And let us see the syntax of defining classes. The basic syntax is very simple. You have the keyword class, and after that, class name. So you are creating a class, and class name is something that has the status of constant. Therefore, it must start with capital letter. So class name must be capitalized. That's why I put here in different color. So class name, and then after that, content, and end at the end. So it starts with class, it terminates with end. What can be used inside are instance variables, which are private, reachable only using accessor methods. They are written as at sign and then variable name after that. So this is instance variable. You know immediately that this is instance variable. On the other hand, there are also class variables that are shared among all instances of a class, and they are written with 2 at signs. So this is the syntactic detail, not particularly important, but it is good that you see immediately what they are. So let us now use this to create a class called box. So what is box? Box is any box that has length, width, and height. So the three uh, dimensions we have. And the class box will start here with the keyword class. Box is capital B because that's the name of the class. And then when we define everything, end will be here. So uh, between class and end, we have to define everything that we want to have in this class. The first thing that you have to define in each object-oriented programming approach is to define the object. So to define the object, you have to have constructor initializer. So constructor initializer has the name initialize. That's the reserved name for it. So you are with function initialize, you are initializing an instance of class box. This instance has three instance variables, length, width, and height. So length, width, and height are going to be three variables that are going to describe each box. So you have this triplet of values that defines the box. Uh, Now, initialize in this case has arguments x, y, and z. So what we want to do is to take this x and initialize length with x, y is going to initialize width, and z is going to initialize height. So length, width, height equals x, y, z. This is constructor and initializer of this object box. So if I want to create a new box, I will, like in all languages, I will have to call box new. So when I say box dot new, that means create a new box. And if you have here value to initialize, then put length is 1, width is 2, and height is 3. So this box dot new creates a new box, a single box. That means a triplet of values, and put inside three numbers, 1, 2, and 3. So box new is creating new box, and then this anonymous box is stored in variable B. Now you have B as the name of object. This is in some kind of symbol table, and then the object itself is stored somewhere in memory. Therefore, what we have is that we created the new box that has name B, and object is in memory. Now, we want to have methods that are applied to this box, and I have only one of them. I want to compute volume of the box. And volume of the box is computed by taking length, multiplying by width, and multiplying by height. So length times width times height are giving me the volume of the box. Pay attention that if you have a language that supports functional programming, then whenever you have a sequence of statements, this sequence returns a value. So I have here that the value that I want to return is this expression, length times width times height. So I could write return length times width times height. However, since this is the last expression that is executed here, because there is only one, so it is the last one, I don't need to put that return. I can just write the expression, and this is going to be returned from this method volume. All methods that you have inside are defined with keyword define and terminated with end, because each function is defined by define and then function name, the list of variables, and then end at the end. So this is function initialize, and this here is function volume. Since they are inside the class box, these are private methods of this class box. They are used on objects that belong to class box. Now, how to use this class? Well, I have here constructor initializer new that is creating new box that has length, width, height 1, 2, 3. storing that in B. Then I can say I want to see what is the volume of that. And volume is, of course, 1 times 2 times 3, which is 6. And I want to display put string volume equals. And then I will take this box B. I will compute volume of it using the method volume. So volume applied to B will give me the volume of the box. And then this method volume works with boxes. So this B must be box. Box.volume is computing volume. Volume is now a number which is either uh, integer or real value. So this is in this case an integer. So I want to display that integer. And therefore, since I do that with string operator put string, I have to concatenate two things, volume equals and b dot volume converted to string. So b is box. Volume is returning another object, which is integer. 2s is converting that to string. And then this plus is concatenating volume and the string that contains 6. So what is going to be printed? What is going to be printed is volume equals 6. Then I can change this B by creating a new box. Box new is 1.1, 2.2, 3.3. So now I have a box with 3 float values and put it also in B. What happens with previous box? Previous box is no longer accessible because this was object created in memory. It was accessible through this name B. Now this B is relinked with this different object. So this old box is now given to garbage collector and say, recycle this, we don't need that anymore. Okay, so I'm creating a new box, which is 1, 1, 2, 2, 3, 3, and then again, volume equals b dot volume dot 2s. So b is box, volume is applied to box to get the volume. Volume is converted to s, which is now different to s than was used here. Why it is different? Because previously 1, 2, 3 were integers and this volume was integer. And this 2s created this string 6. Now I have float values 1, 1, 2, 2, 3, 3. And with these float values, we have that the volume is now a float value, actually 7.986. So I have to create a string that contains this 7.986. And this is, of course, different program from this to S. And of course, when we have that, we create this string and display volume is 7, 9. So there is overloading. This function to S and this function to S are two different functions, but from the standpoint of user, you are simply having that this converts object to string. And whatever is object, it is going to be specialized function that converts that to string. Now, all these objects that I created, this box and this box, were boxes that were having the name B. You can also create an anonymous box which has the quality of constant without having name. So I can say box new here, box new 234. So I'm creating a new box that has length 2, width 3, and height 4. So this is now the new box. And I can apply to this anonymous box method volume. Volume creates now and returns the value of volume, which is 2 times 3, 6 times 4, 24. Then this 2s is converting this 24 to string. And then I'm concatenating this string with volume string, volume equals. And what I get when I display this string, volume equals 24. So what you have here is the way how to create a class, how to create constructor initializer, and how to create methods that are used inside that class. So this is all what you need to create classes of any complexity. And this is here the main program that uses that. All that takes just a few lines of code. So what I want you to do now, think a little bit about other languages that have classes and object-oriented programming and compare how simple is this and how superior is this in simplicity from other languages that do the same thing with plenty of other additional things that have to be done. So it is extremely simple and easy. The instance variables, this here, are accessible to all class member functions. So all of them can access that. Is there any question that I could answer related to creating and using objects? Just unmute your microphone and ask question. Okay. If there is nothing that you want to ask, then let us say that the basic way of creating programs is to expand existing classes. Actually, what you have when you start Ruby, you get this object, but you get here around 100 classes, and each of them has plenty of methods. You have 9,000 methods that come with Ruby. Therefore, you have huge number of classes and methods. And you can try to see what are methods that you get if you start a class to use some of these classes. And here is an example of the class called array. Array is a class that includes the following methods. You can display them. And you see that you have here a shift or sort or to a, convert something to array, or convert array to S, to string, or transpose, reverse, pretty print, and etc., etc. All these methods, each of them has its properties. Then you have to see in documentation of Ruby what they do. But before you start using arrays, it is good to see how these functions work. Some of them are self-evident. For example, if you have empty with question mark, this is obviously the recognizer whether an array is empty. So now, if you want, you can take this array, and the good news is that you can append to this your own methods that you want to use that are specialized in addition to methods that you already have. Okay, so if you want to create such methods, also you see here that in the case of classes, you can use, for example, arrays, you can use equality. So you can check for equality to arrays, what is a nice thing that does not exist in many languages. So let me show you an example of expanding the class array, expanding the class array with three new methods: natural, random, and show. So what I want to do now, I want to create an array and fill it with natural numbers, 1, 2, 3, 4, 5, up to n. So how to do that? We define the function called natural, and here is its argument n. Now, this function now belongs to class array. I am opening the class array, which is not my class, and I have not provided the constructor initializer. Constructor initializer comes with Ruby, and therefore I am having this array here is the class that I'm expanding from here, class, to here, end. So I am expanding it with the function natural of n. And then how to create this array of natural numbers? Well, I first say create a range from 1 through n. So 1, 2, 3, 4, 5 up to n. And then apply method conversion to array, which is called to_a, and apply this method. This dot here tells you that this is one object, and this here is method that is applied to this object, and this expression returns a value that is array that is filled with these numbers. So when I define this, I'm going to create an array that will have n numbers. So if I say array new natural of 100, what is going to happen now? We are going to put here n is 100, and therefore this range is going to be 1, 2, 3, 4 up to 100. We'll convert that to array, and then we are going to display this array. So here it is 1, 2, 3, 4, 5, 10, 20 up to 100. So this array is created with this single line, just a few characters. So this is going to create array, and it is going to convert this range to array, and it is going to return it back to me. So what I'm having here, I'm saying class array new. Class array new is creating a new empty array. Array that has just two brackets. Two brackets means you have an array that has no content inside. And then this function natural of 100, which is our function, is now filling this array with values. So these values are 1 through n converted to a. So this natural is going to create this array. And then when I have this array, I'm going to apply my function show to show components of that array. So this is typical non-procedural object-oriented programming. Take class array, create a new object. After that, fill that object with natural numbers. Then show its contents. So these are all operations: create, fill, show. And they go in this sequence. And each of them is starting with the class name, and then this method returns an object, and this other method creates another object, and this show creates another object. And then, of course, all these must return nil, which is not visible here, but it is returned because all expressions in functional programming return a value. So this is, of course, a program that is written for side effects. I want to see this array. Now, since this is done with this SciTE interface, I have this narrow space for presenting the results. So I want to display these numbers 10 in a single line so that I have them somehow visible, because if I display them here, they're going to be aligned. So what I have this show program that is showing array. So show that uses the current array, and this current array is identified by a pseudo variable self. Self for this, or whatever is the name that in all programming languages, you have that the current object, which is an array, can be accessed using the pseudo variable self. So this self has specific length. So this is method length that is part of methods that creates the value of the object that is composed, how many components you have. So self length tells you you have 100 components. Okay, so 100 times display these values. So times is now iterator. Iterator that has here number, and then times is making iteration 1, 2, 3, 4 up to 100. And I can use counter also. So this times can put counter in this I. Okay. And then if this self is less than 10, I'm going to uh, display uh, I'm going to display it with two spaces between them. So print two spaces if self is 10, and print and after that we are going to have one more space and we'll put self itself here. So I'm printing here just character, and here is another character, and after that comes self of y. So I'm having 1, 2, 3. If this is less than 10, I'm going to put more space between them. And if there is more than 10, I'm going to put only one space, this one here. And then I'm going to put them in a single line. When I put 10 of them in a single line, I'm going to have that 10 plus 1, 9 plus 1. They are going to go from 0, of course, 0, 1, 2, 3, up to 9. So if 9 plus 1 modulo 10 is 0, so if I have here that this is 10, and if modulo 10 is 0, I will put one new line. So put string, for example, after this 50, I'm going to go to 51 to next line. So I have 10 of them in a single line. And this is this show program that is doing nothing important and you don't need it, but it is a method that is now appended to methods of class array. There is another possibility. I can also fill an array with random numbers. How to do that? Random numbers are very useful to study the quality of random number generator. If you want to apply it in Monte Carlo methods, then you need to know that it is good quality. So what I want to do is to create an array and fill it with random numbers. So these 8, 9, 9, 6, 4 are 100 random numbers. Random numbers are created with function rand. Rand, same as in C++. Rand, same function, returns the value between 0 and this limit 10. So it returns values 0, 1, 2, 3, up to 9, not 10. 10 is outside of the range. So it creates 0, 0 through 9. And the random function is going to create array, create a new array with 10 components. Array new of n is creating an empty array with uninstantiated n components. And then you give the method how to fill them. Put inside these brackets function that returns one such value. So array new will now take these values from rand function and will put them inside to create a random array that has n components. When we do that, we can simply say, create new array that has 100 random components and put them in A. So A is now array that has 100 random components. A.show, apply my show method to this array A, and you will create this here list of random values. And then, of course, you can put inside natural numbers. So array new fill with natural numbers, and then show that is the same thing and creates this here. Now, when you have object that is array, Ruby is making attempts to be the first class language. To be the first class language, you must be capable to display objects in human readable form. So this is one of prerequisites to be the first class language. Of course, C++ is not the first class language and cannot show objects unless you write your own overload insert function. But in the case of Ruby, you have a function that is called inspect. Inspect is a library function that is converting any object into some kind of user-readable form. So this is, of course, not particularly elegant because objects can be very different, and therefore this has to show somehow this object. However, for some object, it creates nice output. For some, it creates less nice output. So inspect is going to create an object that is a readable string. And then if you say print inspect, then you are going to print this object that is in human readable form. And this print inspect is abbreviated in kernel method P, which is here. So the simplest way to display any object is to say P, and then after that you have object. And then if I have here array new of 10 natural numbers, I'm creating numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I say P this, I'm going to display this object. And it is doing that in very nice way. It is making here bracket, and then all these components are separated by commas. So I have here 10 components, and I, with this P, display this object. Okay, so by defining these new methods inside an existing class like this array, we of course improve the library of this class with functionality that you need for your program. So you inherit plenty of functions, and you can also append your own functions like show or whatever you want to that class. And so you can grow your software in that way. Very nice property. Now, classes can be built incrementally because here is incremental building of class array. Class array comes prefabricated with methods that belong to that. But then you can open this class and append new methods any number of times. You can do the same thing with your own methods. So you have here class called box, and this class has initialize length with height, and then after that you define length with height is length with height. Pay attention that this is instance variable length, instance variable width, and instance variable height are three instance variables of this class box. Then we have that we assign to length, width, and height these three arguments, length, width, and height. And this is parallel assignment, so everybody is writing in this way, length, width, height equals length, width, height in a single line. This is the simplest possible way. And then, and this is the end of that. So what I have in this class, I have only constructor initializer and nothing else. I am permitted to add to this class whenever I want and whatever I want. So a little later I come and say, hey, here is expansion of this class with two methods. One is called volume, the other is called 2s. So what I'm doing, I'm expanding class box with volume, and volume is length times width times height. So it is just this expression that is going to be computed and returned from volume. On the other hand, I want also to create one nice way how to display the box. Why I need that how to display box? Well, here is the reason. When I create box new of 1, 2, 3, and store that in B, I can say, okay, show me this object box. So P is the kernel method P applied to box B. So print B, display this B. And then here is what is Ruby doing. It is first giving me this pound sign that I don't need. Then it gives me this angular bracket, and then gives the name of the class. Class is called box. And then here is some hexadecimal pointer to this instance that I have. And then here comes the list of instance variables out of order. So the first is length, width, height, but it gives me height, width, and length. So all this is correct. It has here also closing angular bracket. All this is correct, but it is not particularly beautiful. And it is having this pointer that I don't need. And I would like to have something better. What would be better? Better would be to say box and open parentheses and say you have inside 1, 2, 3. This is length, width, height. So this is one nice box that has 3 components, 1, 2, 3. And I want to have this. So to have that, I'm going to create my own function to S. So I'm overloading method to S that is inherited from object. But now I'm having polymorphism. I want to say, if you apply to S to my box, then I want you to display this string, box, colon, open parenthesis, and then put inside length, convert it to string and embed it in this string. So that's this pound saying. Pound says take length and insert it in this string, then put comma and embed inside width and height and close this parenthesis, and this is the string. So to S is going to return a string. So when I say put string for getting one space, so this is this space here, and say take the box and convert to this string, I'm going to get this string box is 1, 2, 3. So put string will be a little better than what I have by P method. Of course, when you are testing your program, you are going to use P method. You don't need to beautify that. But the good news is that I see here the way how 2S works. Because what I want first to do when I create this box that has length, width, height 1, 2, 3, I want to display volume. So put string volume equals plus string B volume converted to string. So what is B? B is this box. Volume is method that is computing the volume of the box. It creates an object of type integer. And then what is this 2S? Is this my 2S? No, it is not, because this 2S is 2S that comes from the class with the class integer. Class integer is having the need to display these values, to convert them from integer to string. So this 2S is converting integers to strings. And after that, this 2S here is not converting integers to string, but boxes to string. So this 2S is my 2S, and this 2S is system 2S that belongs to class integer. The good news is that they are overloaded. You have a kind of polymorphism that this behaves differently depending on what is the data type and class belonging of this object. And the good news is that all of them are called 2S, and you have just to remember 2S converts to string, and therefore I have string. How is this done? It is done somehow internally. Either I do that or somebody else does that for me. And therefore, this is extremely simple and extremely elegant, and therefore can be used in this way. That's how Ruby works. We mentioned self a minute ago, and this is current object invoked by a method. If you look at this self, it looks as a variable. Starts with lowercase. It is a word that is used as identifier or current object, but don't assign values to that. So they look as variables, but that they act as constant, cannot be assigned a value. True and false also looks as a variable. You can have true that you use as a variable. So you ask whether some expression equals false, for example, and you use this false. But false is a variable that has constant value, which is again false and belongs to false class. Nil is empty or uninitialized or invalid. So this is something that belongs to nil class. File and line are in same category of pseudo variables. So how to use self? Here is an example. If I want to test the quality of a sort program, I need an array that I'm going to sort. And it is very convenient to have arrays like this one, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, that repeats any number of times. So if I want to create 1, 2, 3, 1, 2, 3 that repeats any number of times, then when I sort that, the result will be 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. So you're going to have them sorted, and you see how this works. So it is convenient to have this kind of array. Here, I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 that repeats. So I want to create such an array. And to do that, I'm going to create class counter. And class counter will have two components in each object. And each object includes counter and the maximum value, because I have to know to which maximum value I want to go. So if I go 1, 2, 3, max is this 3. So 1, 2, 3, 1, 2, 3 has to have knowledge about the maximum value. And then I have a counter. And this counter will be, during initialization, instantiated with 0. So you can have that instance variable is instantiated not through the list of arguments, but instantiated with any constant value that you want to have. So the object that is created has two components, counter and the maximum value that is taken from this argument. So I have these two things that are characterizing object of class counter. Then I'm creating the method next. Next is going to be applied only to counter. Max is going to be kept constant. And what I'm doing with this counter, I'm incrementing counter by 1. So initially counter was 0, incremented by 1, will create 1, 2, 3, 4, etc. Now, when counter is the small value, when I divide this counter by max, if max is 4 and counter is 1, 1 divided by 4 is 0, because this is integer division. So when I have counter divided by max times max, if counter is less than max, this is going to be 0 times max, 0. So counter will keep incrementing. So a counter will be 1, 2, 3, 4, 5, up to max. When you come to max, you are going to have counter plus 1. So this is max, plus 1 is max plus 1. What happens now? Now this max plus 1 divided by max gives you as the result 1. Then 1 multiplied by max is max. So the value of counter max plus 1 will be decremented by max and will give you 1. So what I got is that you create numbers 1, 2, 3, 4, 5 max, and then boom, down to 1 again. So 1, 2, 3, 4, 5, 6 max, 1, 2, 3, 4, 5, 6 max, 1, 2, 3, 4, 5, 6 max. So you're creating a saw, a kind of increasing sequence that drops down to 1. And that's what I wanted to do. So this is what this next is doing. Then I define an array, which is method of this counter, and I first put inside a temporary array, T, that is defined as empty array. Now this here is exactly the same that you get if you say T equals array.new. If you create array.new, you create array, but this array doesn't have any content. So it is an empty array. It has quality of array, belongs to the class array, but it has no content inside. It is unassigned. So it is shorter to write array is an empty array. So I'm writing here, this is shorter, but you can put array new if you want. So this temporary is now an empty array. Then I use iterator times, so n times is going to create values 0, 1, 2, 3, 4, up to n minus 1. So I have here this k, which is index of this iterator. Iterator will give me indices in this k. And then I'm going to say t of 0 equals self.next. So we'll take the array, and then with next, we'll create a new value. So we'll increment this counter by 1. So self.next will create the new value. And we'll do that n times. How many times? Well, this depends on this argument. So 100 times you go up to 100, and each time are taking self and putting next inside. And each time this is a different one. So you create object.next and put that in T of k. When you finish that, you have this array temporary, and you return the whole array, return T. Now, this is object-oriented language, and any kind of object can be returned with return, which is a very nice thing. Compare this with other object-oriented languages, you will find that you cannot do that. In C++ or in C, you cannot return array at all. You can return pointer if you want, or you can return array by reference, but that means you don't return array at all. You are just saying, where is the array that you modify? So you cannot return array in C++ at all. Here, this is a local object of any complexity. You return it with return from this method. So there is no restriction on that. Very, very nice property. So when I say n equals counter new of 4, I am creating something that is a counter class object, and the maximum is 4. And then say 20 times, put string n dot next. And then when I create that, I create these 20 numbers that have 1, 2, 3, 4. I can also say create counter new of 3 and create array of 10 components, and then display that. So counter new of 3 components, create array that has 10 components, and then with P display this. It is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. So 9 plus 1 is 10. So this is the use of self variable. And we are going to use that many times. Now, whenever you have object-oriented programming, you have that objects that are created by a class are accessible as global variables or class members, therefore to all methods defined inside a class. However, if you have methods that are, if you have main program, then you want to have also possibility to access to instance variables, but you cannot do that because this is encapsulated, and therefore encapsulation is protecting you from doing internal things with instance variables. Therefore, you need getter and setter. Getter and setter. Getter is a method for getting instance variables, object attributes, and setter is a method for writing that for making instance variables. So setter is something that will have a convention that the name usually terminates with equality. So how is this done? Well, here is an example of class box where I initialize length, width, height with x, y, z. So I'm creating an object. If I want to have getter, give the possibility to access this length, then I have to define function that I'm going to call length or any other name. And then this function will return length. The other function width will return width, and so on and so forth. And I have length, width, height that is going to return array that has length, width, height. So this is the way how you can make homemade getters. So then I create a box new 1, 2, 3. I can say length equals, put string length equals, and then box dot length to s. So this looks as a struct where you take a component, because this here actually internally is struct, and this length is its component length. But this here is a getter function. I am invoking this function that is returning length, internal value of object B, and then converting this to S, appending that to length equals, and displaying that as length equals 1. And then width equals 2, etc. So I can create all that with length width height equals, and I have here length width height is 1, 2, 3, which is this here. Now, how to create setters? Setters are also functions that you can define, and I'm defining here function length equals. Now, pay attention that this equal is certainly not assignment. It is the part of name, is character in the name length equals that comes after h. So th equal, this is the name of this function. And then argument of function is written inside the parentheses. And then what I'm going to say, length is this value x. So this is setter. I'm putting inside this value, or putting inside 3 values if I want. So this looks like this. I have method b, and now I want to change this length. That was 1. I want to make it now 4. So to include inside value 4, I'm going to have object b, apply method length equals, and here are parentheses. But parentheses are optional. So I should write b dot length equals of argument 4. But if I omit this parenthesis, which is legal and perfectly okay in Ruby, then I'm going to have something that looks as assignment. So b length equals 4. And therefore, this looks like assigning the value from outside of class, from the main program. So what I have here is something that must be written without. If you put space between with and equal, this is destroying the function, and it is going to create error message. So don't do that. But otherwise, it looks as simple assignment of values. Now, this is extremely simple, but there is even simpler way of doing that by using the attribute accessor, which is a general way of doing that. So Ruby comes with this option called attribute accessor. So if I want to access through getters and setters internal values, I can say, you know what, give me system getters and setters. So providing getters and setters for all instance variables is obtained using attribute accessor. So you say now, give me attribute accessors for length, width, and height. I am having again class box. I am initializing that with length, width, height. So length, width, height is length, width, height. And now I want this length and this width and this height to be accessed through Ruby default accessors. So I'm creating here Ruby box new 1, 2, 3, and then I'm saying length is b length converted to s, width is b width converted to s, etc. So I'm using getters here and displaying length is this, width is this, and height is this. Then after that, I can change with setters this object and say it is no longer 1, 2, 3, now is 4, 5, 6. This is the same object in memory, but now we are modifying its components. Okay. And then when you display that, you get again length, width, and height. Of course, in between, you can, if you want, display with P what are the instance methods that are available. So when you print bot box instance methods minus object instance methods, I'm going to get these methods that I got. And this is length equals width equals height, and height equals. So practically, the instance methods that come with attribute accessor are 6 of them, and I get them for free uh, by asking attribute accessors. So these are same accessors as those that I can do, but they're done by system directly. So very infrequently people will write accessors themselves once if you have already prefabricated accessors. And I cannot think of some better value. So you can say set the value of length or something like that if you dislike this length equal. So you can put your own name, but the functionality is going to be the same. So I don't see many reasons for that. Another again is what is inherited from parents. Well, we have class box that has this method value. And then if I want to see what are the instance methods that are available, there is a function instance methods, instance underscore methods. So this is library function that belongs to object. Object is having these instance methods. So when you say print box instance methods, then you are going to get all these instance methods that are available. So inspect, for example, I said that inspect is converting object to readable form. So inspect is method that exists inside. Clone is for duplication. Then you have instance variables defined. Are they defined or not defined? Then you have a variety of other things. And you also have which is one that we inserted in this list. So these are all methods that are available to you, like class and nil and conversion to A, for example. Where is to A? Somewhere here. Here is to S, conversion to S, that is available to you. So those all things are available, and you can see what are the class box instance method that are not inherited from root class object. So I say print box instance methods minus object instance methods. So when I remove all these instance methods, the only thing that is my own is volume. But I have all others here, which are the part of inheritance from volume. For example, dup, for duplicating objects. This is something that is part of class object. 2A, for example, converting to array is also something that is part of object because you are going to work with various components. So 2A is creating array of components. So all these beautiful things are available, inherited from object. And therefore, object is one way to insert in any new class plenty of useful methods that you can use immediately when you create object of this class. So I'm creating box, but box comes with 30 methods here. Only one of them is mine. The rest I'm going to use because they belong to object from which I inherit. So this brings us to the question of inheritance, because we have to be capable to inherit various values. So let me show you the way how inheritance works. So inheritance works like this. We define a class. So this class is here denoted as old class. And then we want to create class that is a refinement or specialization of the parent class. So all class is usually called superclass or parent class. A new class is used as called subclass or child class. So this child, new class, inherits from old class, which is parent. So when you create a new class that inherits from parent, here is the parent class. And this is inheritance symbol, which is, by the way, identical to inheritance in C++. You remember that it was also with this minus here. So you inherit from previous class. So let us exemplify how this works, how the inheritance works. I'm going to create the class box, and class box is going to be one that has length, width, and height. And I'm going to initialize object length, width, height is length, width, height. Then I'm going to close this class. Then I'm going to open this class again and append to it method volume. Volume returns volume length times width times height. So I have now a constructor initializer, and I have also volume inside. Now, I want to create a new class called color box. This color box is going to be same box as this one, but I want to add new detail to this class. And new detail is two instance variables, color and weight. I want to know how heavy is this box and what is the color used to paint this box. Is it blue or yellow or red or whatever else? Therefore, I'm going to create the new class color box that inherits from class box. And this is done by saying initialize, length, width, height, color, and weight. So these are all instance variables of color box. However, length, width, and height can be inherited from the box. So I will say, wait a second, I'm going to call super, which is going to inherit from box the initialize method, and length, width, and height are going to be used with constructor that comes from parent, this one here. And I'm going to expand that with color is color, weight is weight. So you don't need to put all of them inside because you inherit it from box. So whatever you inherit, you use with super. Super means superclass. Superclass will create length, width, height, and we are going to append color and weight. And this is constructor initializer. Now, I go to create my own 2s function, conversion to string. And I'm going to display box with colon and put this on length, width, height, color, and weight. So I want to get this nice box like this, box colon, 1, 2, 3, color is red, and weight is 1234 pounds. Okay? So when I have this, this 2s is a method that is going to be applied to color boxes. Okay, it is method defined inside color box and works with color boxes. So now I'm creating in the main program color box new that has 1, 2, 3 red and 1234. And then I say print this object B. How is that printed? Well, it looks like this. It has this pound sign, opens this angular bracket and says color box. And here is pointer to it. And then you have height, width, weight, length, and color. So everything out of order. All of them are here. You know what is length? Length is here. And then width is here. And height is here. And color is here last. And weight is here. So it is not, it is first class, no doubt. You cannot complain that this is not in human readable form. Yes, it is. It is human readable. You can see that it is class color box and you see all instance variables. So it is first class, no doubt about that. But it can be beautified. So I'm going to make my own box which looks better. This is much better than this here. Okay. So to do that, we create our own function. And we have here volume is volume plus B, volume to S. This 2s is different from this 2s. This 2s is one that is applied to volume, which means to integer or to float. And here we have put B2s, and this B2s is now box, color box, where we apply 2s function to it. So this is 2s function that is applied for that, and you get this result here. So now, when we have inheritance, we have also possibility to say a few words about class variables. And if you have the possibility uh, to work with accessors, this can fit also here. So let me show this slide here. And when I have this box that I initialize with length, width, height, and I provide these getters and setters, I can use them to get and set variables. And if I want to have a situation that constructor comes without initializer, then you can initialize with default values. So I have here class box that I initialize with 0, 0, 0. So we have boxes that have 0 length, 0 width, and 0 height. So these are, of course, not boxes because they have not these 3 dimensions that are non-zero, but you can initialize that way and provide accessors. So this is the simplest possible thing. It has just 3 lines of code. And you create the box, you create instance variables, and you provide accessors to that. And all that is done with remarkable simplicity. So when I create box new, this is a box that has the value 0, 0, 0. And then I say length is 4, width is 5, height is 6. And then tell me what is length, width, and height. Convert this to S, and you can say length is 4, width is 5, height is 6. So it is having initializer without arguments. So you can do constructor and initialize with some default values, usually zeros or spaces or something like that. Now, class variables have a special syntax. They start with 2 @signs. So all instances share the same class variable prefix, and they are usually used as accumulators or counters. So let me show you an example of their use. What I have here is the situation that I'm going to create boxes. So I am going to say box new 1, 2, 3, and then another box new. And then I'm going to create boxes in an array. So when I do that, I'm going to create plenty of boxes. I want to know how many boxes I created, and I want also to know what is the average volume of each box. So I'm going to create 2 global variables for this box, which are class variables at that box counter that is going to count how many boxes I created. And I'm also creating total volume that is going to be incremented each time when I compute volume. So my constructor initializer is going to have arguments x, y, z, and I will say length with height equals x, y, z. So I'm using constructor initializer that is going to increment the counter variable counter. So at that box counter plus equals 1 is incremented. So you created the new box, and you know how many of them you created. Each time when you create the box, increment counter. So we know how many boxes we have. And then when we compute volume, volume is length times width times height. Then I'm going to add this value to total volume. That was instantiated with 0 initially, of course. So total volume is total volume plus this particular volume. And then I return this volume V. So what I can do now, when the user wants to see the report, I can say, you created this number of boxes, and total volume is this total volume, and mean volume per box is total volume divided by box counter. So this box counter is a counter, and this total volume is accumulator. So I have accumulator and counter, and I can say, you created the total of 6 boxes. Total volume was 73, and mean volume per box was 1233. So this is what this report is giving you. Now the question is how to do that. The first box is box new 1, 2, 3, nothing new. Then I say write the volume of that. So A volume to S is giving this 6. And then create the box with float values 1, 1, 2, 2, 3, 3. And then say volume equals B volume converted to S. So you get volume is 798. And then after that, you say volume equals box new, anonymous box, 234, converted to S, gives you this 24. Then I can define an array of boxes. So C is an empty array. Now I can put inside any objects I want. So I want this to be array of boxes. So I say 3 times, put index in K, and then C of K. So this array C of K is a new box that has the size K plus 1. And after that, I put this volume. So the volume will be 1, 8, and 27. Because this is 1 times 1 times 1. This is 2 times 2 times 2. This is 3 times 3 times 3. So here is an array of boxes. So what I have at the end is the report. And the report tells me, you created 6 boxes. Your 3 here and 3 in this array. So these are 6 boxes that you created. The total volume accumulated is 73.9. Mean volume per box is this one. So now I have a question for you. And this question is, which is the language where you can teach the whole object-oriented programming with creating classes, creating methods, creating accessors, and doing inheritance in a single lecture? Tell me which language you know that you learned all this in a single lecture. Was that C++? Far from that. Was this Java? Very far from that. Well, this is the only language that you can learn about object-oriented programming in a single lecture. This is a remarkable property that I want you to understand as an advantage, fundamental advantage of this language is simplicity. And in engineering, simplicity is everything. If a machine is simple, it is going to work reliably and for a long period of time. If it is complex, it is going to have plenty of opportunities to make errors and mistakes. Therefore, this software engineering machine called Ruby is extremely simple. And that's the property that you can use first to do your homework, which you can now do because you know how to create classes and methods and how to instantiate them. So you can solve the homework and you can prepare for 25% of your final exam, which is going to be one class with inheritance. Is there any question that I can answer now? Is this simple or not? Say yes or no. I would say yes. It is simple.